This is number 7 from the pre-AP review. I've already lined up the x's squared plus the x's plus a blank, then the y squared, the y's plus a blank, and I've moved the constant to the right side with the 2 blanks, just to save a little bit of time. So before I can complete the square, this has to be a 1x squared, so I'm going to factor out 36. So we have 36 times the quantity x squared plus 2x plus a blank, close parentheses. This is a 1y squared, so we don't have to factor out a GCF. Y squared minus 2y plus a blank equals -1 plus 2 blanks. To fill the blanks, we take half of the b term, half of b, and square it. So half of 2 is 1, 1 squared is 1. This is where I always say, but we really didn't just add 1 to both sides because everything inside parentheses is multiplied by 36. We really just added 36 to both sides. And half of -2 is -1, -1 squared is 1, and we did just add 1. So back to the left side, we have 36 times the quantity x plus 1 squared. So the shortcut to that is it's always half of your b term that goes here, plus y minus 1 squared, again, half of your b term, equals 36. We know that ellipses are always set equal to 1, so we'll divide by 36, divide by 36, divide by 36, and our general form transfers into standard form. We have x plus 1 quantity squared over 1 plus y minus 1 quantity squared over 36 is equal to 1. Now we'll graph. I grabbed a little piece of graph paper. We need to start with our center. Our center is located at -1, +1. So H is always with X and K is always with Y. Always looks like the opposite. So we plot -1, 1, put a dot. Then on our x-axis, this value, we take the square root of that value and we move to the left 1 to the right 1. So the square root of 1 is 1, so we move to the left 1 and to the right 1, and the square root of 36 is 6. So on the y-axis, we're going to move up 6 and down 6 from the center. This is a skinny ellipse. All right, so there's our ellipse. These are the vertices. Vertices are the endpoints of the major axis. So our vertices are -1, 7, and -1, -5. The co-vertices are the endpoints of the minor axis. So our co-vertices are -2, 1, and 0, 1. All right, to find the length of the major axis, you can just count it. It was up 6, down 6, so the major axis is 12 units long. And the minor axis was to the left 1, to the right 1, so the minor axis is 2 units long. In an ellipse, this is very important. A squared is always greater than b squared. So that means that the 36 is the a squared and the 1 is the b squared. This little fact is important because we have c squared equals a squared minus b squared to find the foci. That's to find little c, which is the distance to a focus. So c squared equals a squared, 36, minus b squared, 1. So c squared is equal to 35. So c is equal to the square root of 35. which is approximately 5. I'm just going to guesstimate 5.9, approximately 5.9 units long. So on the major axis, we're going to count 5.9 units up. 1, 2, 3, 4, 5.9. We'd have a focus right about there. And 5.9 down. 1, 2, 3, 4, 5.9 right in there. So it's very, very, very close. It's because it's so narrow. The foci are always on the major axis, and they are always C units from the center, so approximately 5.9 units from the center. Now the coordinate of the foci. The coordinates of the foci, we take our center, we use our center, and since we moved up and down to put the foci in, we moved up 5.9 or square root of 35 and down 5.9 or square root of 35. That is a move on the y-axis. So we leave the center's x value alone. We take the center's y value, we add and subtract the square root of 35, and those are the two foci. I think that's it for the ellipse. So I'll go ahead and save this.